Hey Global Impact students, this is Mr. Ellinger. This lesson is on an introduction to equations. Our learning target is to solve equations using tables and mental math. Essential understanding: sometimes the value of one quantity can be found if the value of another is known. Also, the relationship between the quantities can be represented in different ways, including tables, equations, graphs, and words. Those four things: table, equation, graphs, and words. We call that the rule of four. That rule of four, you're going to hear that over and over and over again, all the way up through calculus, all your math classes at Global Impact. We have to be able to use all four representations. Background for this lesson: equations bring together many important algebraic concepts such as variables, expressions, and the order of operations. Often in the study of algebra, we become mechanical when solving equations and lose sight of the many non-algebraic methods that we know for solving problems. We also lose sight of what it means for a number or numbers to be the solution or solutions of an equation. Stressing the importance of these non-algebraic methods like making a table or using a number line will aid us when we need to judge the reasonableness of a solution, solve a word problem, or graph a linear equation. First, recall from a previous lesson that an equation shows that two expressions are equal. Equations can fall into one of three categories. We could have a true equation, where the left side equals the right side after both sides are simplified. We can have a false equation, where the left side does not equal the right side after both sides are simplified. Or we can have an open equation. These are equations that have variables in them. So here I have three equations, 1, 2, 3. We want to be able to determine or look at the equation and know whether it's true, false, or open. So my first example, 3y plus 6 equals 5y minus 8. That's what we call an open equation. It's open because we don't know if it's true or false because we don't know what y is. If we were given a value of y to test, then we could say whether it's true or false based on the value of y. Our second equation is 16 minus 7 equals 4 plus 5. We don't have any variables here, so we're going to be able to determine whether this is true or false. So let's just simplify both sides. 16 minus 7 is 9. 4 plus 5 is 9. Okay, so here we have a true equation. And it doesn't matter how complex the left side or the right side are. If it's a numerical equation, we can simplify the left, simplify the right, and determine whether it's true or false. Our third equation, we have 32 divided by 8 equals 2 times 3. Again, all numbers, so we can simplify both sides. 32 divided by 8 is 4. 2 times 3 is 6. Those two are not equal, so that is a false equation. A number is a solution to an equation if the number satisfies the equation, meaning if the possible solution is substituted in for the variable or variables in the equation is true after both sides are simplified. So the question is m equals 1/2 a solution of 6m minus 8 equals negative 5? So we were given a possible solution, and we want to determine if it is in fact a solution or not. So what we do is we take our equation, then we substitute the possible solution in for the variable. So we put 1/2 in for m, and just simplify. 6 times 1/2 is 3. 3 minus 8 is negative 5. We had nothing to simplify on the right. We had a value of negative 5. Negative 5 on the left, negative 5 on the right. That is a true statement or true equation. So we would say yes, m equals 1/2 is a solution. So you might ask yourself, well, are there other solutions? Are there any other solutions to the equation? In this case, when we only have one variable, m, no exponents, then there's only going to be one solution to an equation. Later we'll look at equations that have two variables, have more than one solution. We'll look at equations that have exponents. They will have more than one solution. But for now, if we have one variable, one type of variable, just m, in this case, then we're only going to have one solution. Here's a critical skill that we have to have moving forward. We must be able to take a word problem, translate it into useful mathematics. I mentioned this back in the very first lesson of Algebra 1. This is going to allow us to solve the problem we're being asked. So here's an example. The length of the ball court at La Venta is 14 times the height of its walls. Write an equation that can be used to find the height of a model that has a length of 49 centimeters. So we have this court. They're building a model of the court. We need to write an equation that allows us to find the height of the model. So basically we have to translate all of this into an equation that we can use. Now, there is a small, teeny tiny word in this whole problem that's very critical, and it's right here. The word is. When you see the word is in a statement, is means equal. So we have two things that are going to be equal. And if we take this first sentence tells us the relationship between two variables in this case. We have a length of a ball court and we have the height of the walls of the ball court. So we have a length and we have a height. Anytime we want to write an equation, we have to have variables. So we identify the quantities in the problem, and we'll go ahead and assign variables for those quantities. So for L, we can use L, cursive L, H for height. Now, what is the relationship between the length and the height in this problem? Well, the sentence tells us that the length equals, or it says is, so we'll put equals 14 times the height of the walls. So in words, there's the relationship. The length equals or is 14 times the height. Well, we don't want words in an equation, we want variables. So this is where assigning variables for these values comes in handy. L equals 14H. That's our equation. That's our relationship. Okay? It's always a good idea to write out in words the relationship first and then write the equation. Sometimes if we try to jump straight to the equation, we miss the relationship aspect of this, and it's a very critical part to algebra. But now that we have the equation, the problem doesn't ask us to find the height, but now we could find the height. The solving that we're going to do in this lesson, we're going to use mental math. That's one tool that we're going to use. Mental math just means do it in your head. Many times we can solve equations by asking ourselves what value of the variable would make the equation true. That's really what solving equations in your head is about. For now, this will be enough, but very soon we will not want to solve everything in our heads, nor will you be allowed. If it doesn't specifically say use mental math, then I'm going to expect that you show work. When we get to Unit 2, you will have to show work when we're solving equations. So here's an example. We're going to solve the equation for y. So we're going to ask ourselves, what value of y makes the equation true? So when we look at this equation, we've got 12 minus y equals 3. We want to know what value of y, if we were to plug it in or substitute it in for y, would make this a true statement. So we ask ourselves, 12 minus what equals 3? 12 take away what equals 3? Well, y is going to be 9. 12 minus 9 is 3. That's mental math. Another way that we can solve an equation is by making a table of values, but this is not the most practical way. What is the solution of 5n plus 8 equals 48? Use a table. So here's a worked out example of how you would go about using a table to solve an equation. We'll make a table of values, meaning we'll pick values of n in this case. We'll plug them in or substitute them into our expression on the left and see if it equals 48. Choose a starting value using mental math. So we'll start with 1. 5 times 1 plus 8 equals 13. And 5 times 10 plus 8 equals 58. So 1 is too low, because that gives us a value of 13. 10 is too high, that gives us a value of 58. We want a value for that expression to be 48. So it's somewhere between 1 and 10. So we just pick some values. So we'll start off with n equals 5. 5 times 5 is 25, plus 8 is 33. 6, use 6 for n. 5 times 6 is 30, 30 plus 8 is 38. We're getting there. If n is 7, 5 times 7 is 35. 35 plus 8 is 43. We're getting close to 48. If n is 8, 5 times 8 is 40, plus 8 is 48. There we go. We have the value that we're looking for. Again, we want to know when does 5n plus 8 equal 48, because that's what our equation says. So when n is 8, the left side of our equation is 48, and that gives us a true equation. So the solution is n equals 8. So let's try this. What is the solution of 3x plus 3 equals negative 22? Use a table. All right, so we're going to make a table. So here we want to know, we want this left side to equal negative 22. So if you look at it, we're going to take 3 times something and add 3 to it. And we need it to be a negative number. So our x values right away we know need to be negative. Also, we're going to add 3. So we want to reduce, or this product, we're going to change this product by 3 units to make it negative 22. So we're going to want this product to be somewhere in the 20s, maybe upper teens, because we're going to change its value by 3 to get negative 22. So let's just start off with negative 5. If x is negative 5, our expression looks like this. 3 times negative 5 is negative 15. Negative 15 plus 3 is negative 12. Not negative 22. If x is negative 6, 3 times negative 6 plus 3. 3 times negative 6 is negative 18. Negative 18 plus 3 is negative 15. If x is negative 7, 3 times negative 7 plus 3. 3 times negative 7 is negative 21, plus 3 is negative 18. If x is negative 8, 3 times negative 8 plus 3. 3 times negative 8 is negative 24, plus 3 is negative 21. And you might notice a pattern here. As x decreases by 1, our values are decreasing by 3. You might notice something, but let's continue on. If x is negative 9, 3 times negative 9 is negative 27. Negative 27 plus 3 is negative 24. We missed negative 22. Somewhere in between here, right? So our answer is somewhere between negative 8 and negative 9. So can we use a table to do this problem? The answer is no. We have to have some other techniques. Not every equation can be solved by using a table. The point of this, not every equation can be solved using mental math. This value of x to solve this equation is going to be a decimal or a fraction. And we can't get those from our head or from a table. We have to have other techniques. And we'll learn those other techniques in Unit 2. Have a good day.